Implementation of Autonomous AI Scientists by 2024, a comprehensive overview. Executive Summary. The projected implementation of autonomous AI scientists by 2024 is poised to transform various scientific sectors through a structured approach involving 4 key stages backed by an investment of $10 million. This initiative focuses on data integration, machine learning optimization, ethical compliance, and deployment for continuous improvement. The overarching goal is to enhance research efficiency and ensure responsible AI utilization in scientific inquiries. Key stages of implementation. 1. Data integration. The first phase of the initiative emphasizes the critical task of data integration. This stage aims to compile heterogeneous datasets from various scientific fields, creating a comprehensive database that AI systems can leverage. The integration process will involve identifying relevant datasets across disciplines such as biology, chemistry, physics, and environmental science. Developing robust data processing systems capable of handling large volumes of information efficiently. Establishing protocols for data standardization to ensure compatibility and facilitate seamless analysis. Effective data integration is fundamental for the subsequent stages as it provides the essential foundation upon which machine learning models can be built. 2. Machine learning optimization. Following successful data integration, the focus will shift towards optimizing machine learning algorithms. The objectives of this phase include refining existing algorithms to improve their predictive accuracy and efficiency in scientific contexts. Tailoring AI models to address specific scientific questions, enabling them to generate hypotheses and design experiments autonomously. Conducting iterative testing and validation to ensure that the AI models perform reliably under various conditions. By enhancing the capabilities of machine learning systems. The initiative aims to empower AI scientists to conduct complex analyses and generate insights that were previously unattainable. 3. Ethical compliance frameworks. As AI systems assume greater autonomy, the establishment of ethical compliance frameworks becomes paramount. This stage will focus on developing comprehensive ethical guidelines governing AI deployments in scientific research. Implementing mechanisms to mitigate bias in data processing and decision-making, ensuring fairness and accuracy in AI-driven outcomes. Ensuring transparency in AI operations. Allowing for scrutiny and accountability in the scientific community. Establishing a strong ethical framework will not only foster public trust but will also safeguard against potential misuse of autonomous AI technologies. 4. Deployment and continuous improvement. The final stage involves deploying the AI systems in real-world scientific environments and establishing a framework for ongoing evaluation and enhancement. Key components of this phase include collaborating with research institutions and laboratories to implement AI solutions in live settings. Establishing feedback loops to gather data on AI performance and user experience, facilitating continual refinement of the systems. Exploring avenues for scaling AI applications across diverse scientific disciplines. Fostering interdisciplinary collaboration. This dynamic approach ensures that the autonomous AI scientists remain relevant and effective amid evolving scientific challenges and discoveries. Investment and impact. The total projected investment of $10 million will be strategically allocated across the 4 stages of implementation. This funding is vital for developing the necessary technology infrastructure for data integration and machine learning optimization, supporting research and development initiatives focused on ethical compliance and safety standards, facilitating partnerships with academic and research institutions for practical deployment of AI solutions. The anticipated impact of this initiative is profound, with potential benefits including accelerated scientific discoveries, enhanced research productivity, and improved public health outcomes through advanced analytics. Common themes across sources. 1. AI integration. The necessity for effective integration of diverse data sources is universally acknowledged as a prerequisite for achieving reliable scientific outcomes. 2. Machine learning optimization. There is a consensus on the importance of optimizing machine learning processes to enhance the efficiency and effectiveness of AI systems in scientific research. 3. Ethical considerations. The establishment of robust ethical compliance frameworks is recognized as a critical component of deploying autonomous AI, addressing concerns surrounding bias and accountability. Differences in perspectives. While most sources emphasize the technical aspects of AI implementation, some highlight the broader societal implications of autonomous AI scientists, including concerns regarding job displacement in traditional scientific roles due to automation, the need for strategic investment in workforce reskilling to adapt to an AI-driven research landscape. Moreover, some discussions focus on the funding strategies, noting that the $10 million investment could be part of a broader trend in AI investments across various sectors. Timeline of events. 2023, initial discussions and planning stages for autonomous AI scientists commence, focusing on identifying critical datasets and potential applications in various scientific fields. 2024, the 4 stages of implementation are initiated with an emphasis on data integration and the establishment of machine learning frameworks. 2025, a full rollout of the AI scientists is anticipated, accompanied by continuous monitoring and improvements based on real-world feedback and scientific advancements. Conclusion. The implementation of autonomous AI scientists by 2024 represents a significant technological advancement in the field of scientific research. Through a well-structured approach supported by substantial investment, this initiative is designed to ensure that these AI systems are not only effective but also ethical and beneficial to society as a whole. The structured phases of implementation will facilitate the successful integration of AI into scientific endeavors, paving the way for a new era of discovery and innovation. The implementation of autonomous AI scientists by 2024 is projected to unfold through 4 critical stages, supported by an anticipated investment of $10 million. This initiative aims to revolutionize various sectors by integrating data, optimizing machine learning processes, and ensuring adherence to ethical compliance frameworks. Key stages of implementation. 1. Data integration. The initial stage focuses on consolidating diverse datasets from various scientific domains to create a robust foundation for AI systems. This involves developing systems capable of processing and analyzing vast amounts of scientific data efficiently. 2. Machine learning optimization. Following data integration, efforts will shift towards refining machine learning algorithms to enhance their predictive abilities and accuracy. This stage aims to tailor AI models specifically for scientific inquiries, making them more effective in generating hypotheses and conducting experiments. 3. Ethical compliance frameworks. As AI systems become more autonomous, it is crucial to establish ethical guidelines to govern their operations. This stage will focus on developing legal and ethical frameworks to ensure that AI scientists operate responsibly, avoiding biases and maintaining transparency in their decision-making processes. For deployment and continuous improvement, the final stage will involve deploying the AI systems in real-world scenarios while continuously monitoring and improving their performance based on feedback and new scientific discoveries. Investment and impact. The total projected investment of $10 million underscores the commitment to bringing these AI scientists to fruition. Reports indicate that this funding will be allocated strategically across the 4 stages, ensuring that each phase receives the necessary resources to succeed. Common themes across sources. 1. AI integration. There is widespread agreement on the necessity of integrating various data sources to enhance the capabilities of AI scientists. This integration is seen as fundamental for achieving accurate and reliable scientific outcomes. 2. Machine learning and optimization. Many sources highlight the importance of optimizing machine learning processes to improve the efficiency and effectiveness of AI systems in scientific research. 3. Ethical considerations. The need for ethical compliance frameworks is a recurring theme, with many recognizing the potential risks associated with autonomous AI decision-making. Differences in perspectives. While the majority of sources emphasize the technical aspects of AI implementation, some highlight the broader societal implications, such as the potential for job displacement in traditional scientific roles. Others focus on the investment strategies, noting that the $10 million funding might be part of a larger trend in AI investments across various sectors. Timeline of events. 2023, initial discussions in planning stages for autonomous AI scientists begin focusing on identifying critical datasets and potential applications in various scientific fields. 2024, the 4 stages of implementation are set in motion, with a focus on data integration and the establishment of machine learning frameworks. 2025, a full rollout of the AI scientists is expected, with continuous monitoring and improvements based on real-world applications and feedback from the scientific community. In conclusion, the implementation of autonomous AI scientists by 2024 is not only a technological advancement but also a significant step towards reshaping scientific research. The structured approach, supported by substantial investment, aims to ensure that these systems are effective, ethical, and beneficial to society at large. Counterintuitive insights. 1. Job displacement versus job creation. While many discussions around AI implementation focus heavily on the potential for job displacement, particularly in traditional scientific roles, there are also arguments suggesting that the introduction of autonomous AI scientists could create new kinds of jobs and roles that prioritize human oversight, ethical governance, and creative problem-solving, tasks that AI cannot currently replicate. This shifts the narrative from solely seeing AI as a job replacer to viewing it as a catalyst for new job creation in sectors that manage and work alongside AI technologies. 2. Ethics frameworks as a competitive advantage. The emphasis on developing ethical compliance frameworks for AI scientists might seem like a regulatory burden. However, establishing strong ethical guidelines could become a competitive advantage. Organizations that prioritize ethics in AI development may gain public trust, leading to higher acceptance and adoption rates of their technologies. This contrasts with the belief that ethical considerations could slow down technological advancement. 3. Investment allocation strategy. The $10 million investment may appear modest in the context of AI development, especially when compared to the billions flowing into other tech sectors. Yet the strategic allocation across the 4 implementation stages suggests a focused and disciplined approach, which may yield better long-term results than larger, less organized investments. This could challenge the perception that success in AI requires massive financial backing without a clear plan. 4. Data integration's role in AI efficacy. The focus on data integration as the first step of implementation might seem like a straightforward technical necessity. However, it highlights an often overlooked counterintuitive insight. The quality and diversity of data used to train AI models can have a more profound impact on their effectiveness than the sophistication of the algorithms themselves. This undermines the narrative that cutting-edge algorithms alone drive AI success. 5. Continuous improvement as a core principle. The inclusion of continuous improvement as a core principle of deployment might seem standard in technology projects. However, this approach implies an ongoing commitment to learning and adapting, which contrasts with the typical tech industry mindset of launching and moving on. This can lead to better alignment with scientific discovery processes, where iteration and refinement are essential, challenging the notion that tech implementations are typically static once deployed. These insights challenge prevailing assumptions about AI development and its societal implications, emphasizing the complexity and multifaceted nature of implementing autonomous AI scientists. The report on the implementation of autonomous AI scientists by 2024 outlines a transformative initiative that many may overlook in its technical and ethical implications. Here are key aspects that warrant further attention. 1. Data integration. Significance. The focus on data integration is critical because it lays the groundwork for effective AI operation. Many reports may gloss over the complexity involved in integrating diverse scientific datasets, which can include structured and unstructured data from various domains. This integration is not merely a technical hurdle, it shapes the AI's ability to generate accurate predictions and insights. A robust data integration framework ensures that AI can access rich, varied data, enabling it to form comprehensive hypotheses and conduct experiments effectively. Overlooked aspect. The challenge of ensuring data quality and relevance is often understated. Poorly integrated data can lead to biased or irrelevant AI outputs, which could undermine trust in AI-generated scientific findings. 2. Machine learning optimization. Significance. The optimization of machine learning algorithms is another technical facet that deserves scrutiny. While the report mentions enhancing predictive abilities and accuracy, it's crucial to recognize that poorly optimized models can result in significant inefficiencies and errors in hypothesis generation and experimentation. This can have cascading effects in scientific research, potentially leading to flawed conclusions. Overlooked aspect. Many discussions about AI optimization ignore the iterative nature of machine learning development. Continuous feedback loops, rigorous testing, and adaptation are essential for refining AI models, which requires sustained investment and commitment beyond the initial deployment phase. 3. Ethical compliance frameworks. Significance. The establishment of ethical compliance frameworks is paramount as AI scientists become more autonomous. The report highlights the need for governance to avoid biases and ensure transparency, yet the specifics of these frameworks can easily be overlooked. Ethical considerations must be integrated into every stage of AI development, from data collection to decision-making processes. Overlooked aspect. The potential legal implications of AI decisions are often underestimated. As AI systems make more autonomous decisions, the accountability for those decisions, especially in sensitive areas like healthcare or environmental science, comes into question. Who is responsible for an AI's erroneous conclusion? This ambiguity can pose significant risks for organizations deploying AI scientists. 4. Deployment and continuous improvement. Significance. The report's final stage emphasizes deployment and continuous improvement, which is crucial for ensuring that AI systems remain effective in real-world applications. This phase involves not just the initial rollout but also ongoing refinements based on real-world feedback, which is essential for adapting to new scientific discoveries and evolving ethical standards. Overlooked aspect. The relationship between AI systems and the scientific community is a vital consideration that may not be fully appreciated. Continuous improvement should involve collaboration with researchers and domain experts to ensure AI tools meet the practical needs of the scientific community, fostering a symbiotic relationship rather than a competitive one. 5. Investment allocation. Significance. The projected investment of $10 million is a significant commitment. But the allocation of these funds across the 4 stages is crucial. Reports often focus on the total financial commitment rather than the strategic choices behind the investment. Overlooked aspect. The potential for misallocation of resources can hinder the initiative's success. For instance, if too much funding is directed toward initial data integration at the expense of ethical compliance frameworks, it could lead to long-term issues of trust and reliability in AI outputs. 6. Broader societal implications. Significance. While the report addresses technical aspects, the societal implications of deploying autonomous AI scientists are profound. This includes potential job displacement in traditional scientific roles and the ethical ramifications of AI-driven research. Overlooked aspect. The need for retraining and upskilling the workforce to adapt to an AI-augmented scientific landscape is often under-discussed. Preparing the current workforce for collaboration with AI systems can help mitigate fears of job loss and promote a more inclusive transition to an AI-enhanced future. 7. Cultural and legal considerations. Significance. Different cultural and legal contexts will influence how AI is integrated into scientific research globally. The report's implications may vary significantly across regions with divergent regulatory frameworks and cultural attitudes toward AI. Overlooked aspect. The potential for international collaboration or conflict in AI development can shape its global impact. Understanding these dynamics is essential for creating frameworks that are adaptable and sensitive to regional differences. In conclusion, the report on the implementation of autonomous AI scientists by 2024 carries with it profound implications that extend beyond technical execution. Addressing the overlooked aspects such as ethical frameworks, societal impacts, and the continuous improvement cycle is vital for realizing the full potential of this initiative while ensuring responsible and equitable deployment in the scientific community. Here are the 4 most valuable points from the content regarding the implementation of autonomous AI scientists by 2024. 1. Data integration. The first stage of implementing autonomous AI scientists involves data integration, which focuses on consolidating diverse datasets from various scientific domains. This is crucial as it creates a robust foundation for AI systems to analyze and process vast amounts of scientific data effectively. The success of AI in scientific research heavily depends on the quality and breadth of the datasets used for training. By integrating data from different sources, the AI can gain a comprehensive understanding of various scientific phenomena, leading to more accurate predictions and insights. This stage not only sets the groundwork for the AI's functionality but also ensures that the AI can operate across multiple fields of study, enhancing interdisciplinary research capabilities. 2. Machine learning optimization. Following data integration, the next critical stage is machine learning optimization, which focuses on refining algorithms to enhance their predictive capabilities and accuracy. This stage aims to develop tailored AI models specifically designed for scientific inquiries. By optimizing machine learning processes, the AI can generate hypotheses and conduct experiments more effectively, mimicking the thought processes of human scientists. The emphasis on optimization is essential for improving the efficiency of research and accelerating the pace of scientific discoveries. This stage highlights the importance of continuous improvement in AI algorithms to adapt to new data and scientific challenges. 3. Ethical compliance frameworks. As autonomous AI systems become more integrated into scientific research, the establishment of ethical compliance frameworks is paramount. This stage focuses on developing guidelines to govern the operations of AI scientists, ensuring that they operate responsibly and transparently. Ethical considerations include addressing biases that may arise from data, maintaining accountability, and ensuring that AI decisions are understandable and justifiable. As AI systems take on more autonomous roles, the potential risks associated with their decision-making processes necessitate a framework that prioritizes ethical standards, reinforcing public trust in AI technologies. This point underscores the critical intersection of technology and ethics, which is often a focal point in discussions about AI deployment. 4. Deployment and continuous improvement. The final stage of the implementation process is deployment and continuous improvement, which involves releasing AI systems into real-world scenarios and refining their performance based on feedback and new scientific insights. This stage is vital as it ensures that the AI systems can adapt to practical challenges and continually evolve to meet the dynamic needs of scientific research. Continuous improvement mechanisms allow for the integration of new findings and the correction of any shortcomings observed during deployment. This iterative approach not only maximizes the utility of AI scientists but also fosters a culture of innovation and responsiveness to emerging scientific questions. These points collectively reflect the multifaceted approach necessary for the successful implementation of autonomous AI scientists, emphasizing the interplay between technical optimization, ethical considerations, and practical application in scientific research. This structured framework aims to ensure that the deployment of AI technologies is both effective and responsible, ultimately transforming the landscape of scientific inquiry by 2024. 1. The Manhattan Project 1942–1946. The Manhattan Project was a secret U.S. government research project during World War II that aimed to develop atomic bombs. It involved the integration of vast amounts of scientific data and collaboration among scientists from various fields including physics, chemistry, and engineering. The project was marked by its rapid development and optimization of nuclear technology, culminating in the successful detonation of atomic bombs in 1945. Ethical considerations arose regarding the use of such devastating technology, leading to ongoing debates about nuclear weapons and their implications for global security. 2. Genetic Engineering and the Human Genome Project 1990–2003. The Human Genome Project was an international scientific research initiative aimed at mapping and understanding all the genes of the human species. It involved extensive data integration and collaboration among scientists worldwide. The project not only optimized genetic research techniques but also raised significant ethical questions related to genetic privacy, potential discrimination, and the implications of genetic modifications. As advancements in genetic engineering continue to evolve, the ethical frameworks established during this project remain critical in guiding responsible research and application. 3. The development of autonomous weapons systems 2010s present. The increasing reliance on artificial intelligence and machine learning in military applications has led to the development of autonomous weapons systems capable of making life-and-death decisions without human intervention. This trend has raised profound ethical and legal concerns regarding accountability, transparency, and the potential for misuse. Efforts to establish ethical compliance frameworks for these technologies echo the discussions surrounding the implementation of autonomous AI scientists. The ongoing debates about the implications of autonomous weapons systems highlight the importance of ensuring responsible innovation in AI. The implementation of autonomous AI scientists is set to transform various sectors by 2024, progressing through 4 key stages with a projected investment of $10 million. This initiative represents a significant leap in scientific research and application, driven by advancements in data integration, machine learning optimization, and ethical compliance frameworks. Key stages of implementation. 1. Data integration. This foundational stage involves consolidating diverse datasets from multiple scientific domains. Developing systems that efficiently process and analyze large volumes of scientific data is paramount. This integration will establish a robust knowledge base for AI systems, enabling them to draw insights and correlations effectively. 2. Machine learning optimization. After establishing a comprehensive data repository, the focus will shift to refining machine learning algorithms. The goal is to enhance predictive capabilities and ensure accuracy in AI models tailored specifically for scientific inquiries. This stage will allow AI systems to generate hypotheses, design experiments, and analyze results with greater efficiency. 3. Ethical compliance frameworks. As AI systems become more autonomous, establishing ethical guidelines becomes crucial. This stage will develop legal and ethical frameworks to govern AI operations, ensuring transparency, accountability, and the avoidance of biases in decision-making. Compliance with these frameworks will build public trust and facilitate smoother integration into existing scientific practices. For deployment and continuous improvement, the final stage involves deploying AI systems in real-world scenarios. Continuous monitoring and iterative improvements based on user feedback and new scientific discoveries will be essential. This adaptive approach will ensure that AI scientists remain relevant and effective in addressing evolving scientific challenges. Investment and impact. The anticipated investment of $10 million emphasizes the commitment to realizing autonomous AI scientists. This funding will be strategically allocated across the 4 implementation stages, ensuring that each phase receives the necessary resources to succeed. The impact of this initiative is expected to be profound, potentially accelerating scientific discovery across fields such as healthcare, environmental science, and materials engineering. Common themes and perspectives. Across various sources, several common themes emerge. AI integration. There is a consensus on the necessity of integrating various data sources to enhance the capabilities of AI scientists. This integration is seen as fundamental for achieving accurate and reliable scientific outcomes. Machine learning optimization. Many sources highlight the importance of optimizing machine learning processes to improve the efficiency and effectiveness of AI systems in scientific research. Ethical considerations. A recurrent theme is the need for ethical compliance frameworks, with many recognizing the potential risks associated with autonomous AI decision-making. Differences in perspectives. While most sources emphasize the technical aspects of AI implementation, some highlight broader societal implications such as the potential for job displacement in traditional scientific roles. Others focus on investment strategies, noting that the $10 million funding might be part of a larger trend in AI investments across various sectors. Timeline of events. 2023. Preliminary discussions and planning for autonomous AI scientists commence, focusing on identifying critical datasets and potential applications in various scientific fields. 2024. The 4 stages of implementation are initiated, concentrating on data integration and establishing machine learning frameworks. 2025. A complete rollout of AI scientists is anticipated, with ongoing monitoring and enhancements based on real-world applications and community feedback. Future outlook. Looking beyond 2025, the development of autonomous AI scientists is likely to continue expanding, with several key predictions. 1. Widespread adoption. By 2030, autonomous AI scientists could become commonplace in laboratories, research institutions, and even corporate research departments, significantly enhancing productivity and accelerating innovation cycles. 2. Enhanced collaboration. Future AI systems may facilitate collaborative research efforts across global institutions, enabling scientists to share data and insights in real time, leading to faster and more impactful discoveries. 3. Interdisciplinary applications. As AI scientists evolve, their capabilities could extend beyond traditional scientific domains, contributing to fields such as social sciences, behavioral research, and even arts, thereby fostering interdisciplinary collaboration. 4. Regulatory frameworks. As the use of AI in science becomes more prevalent, regulatory frameworks will need to evolve to manage ethical concerns, data privacy, and accountability, ensuring that AI technologies serve the public good. 5. Continuous learning and adaptation. Future AI systems will likely incorporate mechanisms for continuous learning, allowing them to adapt and enhance their capabilities based on new data and evolving scientific paradigms. In conclusion, the implementation of autonomous AI scientists by 2024 is poised to revolutionize scientific research. By focusing on data integration, machine learning optimization, ethical frameworks, and continuous improvement, this initiative will ensure that AI technologies are effective, responsible, and beneficial to society at large. The future holds exciting possibilities for AI in science, with the potential to reshape how knowledge is generated, shared, and applied across various fields.